Okay. Anyway, actually, it will be a very short class. Let's see how much I can go. Anyway, in the last class, we are talking about the binomial random variable, isn't it? If I can remember it correctly.
Yes, sir.
We in the last class, we were talking about this binomial random variable. And this binomial random variable, we have seen how it works. And then today, we will see the Pascal random variable. Okay. The Pascal random variable actually, before going in detail, let us solve this example. Example 2.15. Okay. Suppose you test circuits until you find K rejects. Let L equal the number of tests. Okay. So what actually we are doing here? We are actually talking about this K rejects. Look at this one. You test circuits until you find K rejects. Say for example, let L equal the number of tests. So for example, I'm talking about L tests. Okay, 1, 2, 3, 4, like this L tests. Okay, so we are having L number of tests. Okay, then remember one thing, you test circuits until you find K rejects. So the first one can be a reject. We know that the rejection probability is small p. So the first one can be reject. Second one can be accept. Third one can be reject. Fourth one can be accept. Fifth one can be also accept. Sixth one can be a reject. Like this, say k equals to 4 rejects. What does it mean? If all these are accept, then can we stop testing?
No.
I've tested 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tests. And I have found 3 reject. But I need to find 4 reject. So definitely I have to test again to find the reject, but it is also accept. So I have to test again and get the rejection. Now I am getting a reject. Now the 4 reject criteria is fulfilled. Now what can I say? That now I can stop. So whenever you test, the last one must be a reject um, in this pattern, or I can say in this Pascal random variable. Do you agree?
Yes, sir.
So the idea is, whenever you are testing L circuit, then the last one is a reject. Actually, I don't know whether L is actually what. The last one is a reject, definitely, because the K number of reject we have to find, and then we will stop. So definitely the last one is a reject. So if I just ignore the last one, if I am talking about this particular number of um, circuits, then can I say that out of this L minus 1 number of tests, I will have K minus 1 number of reject. Can I say that?
Yes, sir.
Just think about it. The last one has to be a reject. So I cannot tell about the last one. So if I want to say, then actually out of the L number of tests, if I ignore the last one, there will be L minus 1 number of tests remaining. And definitely the last one is a reject. So K minus 1 number of reject are there. out of L minus 1 number of tests. So this one is similar to that of binomial theorem. Can we say that? Can we say that this one is actually one kind of binomial random variable? Out of L minus 1, I am having K minus 1 reject. The same thing was told in the binomial random variable, isn't it?
Yes, sir.
So if I ignore this last one, I can say that the remaining one is something like a binomial random variable. And we can say that L minus 1 C K minus 1. That was the binomial theorem, isn't it? And the probability was what? K minus 1 reject. So definitely P to the power K minus 1. P to the power K minus 1. And then other will be 1 minus P, isn't it? Others will be 1 minus P. Others will be 1 minus because they are accept. They are accept. So how many accept? L minus K minus bracket K minus 1, isn't it? So can we say that into 1 minus P to the power L minus 1 minus K minus 1. Can I say that?
Yes.
Just think about the binomial theorem. What was the binomial theorem? If you just go to your previous um, um, class, and you can see that it was something like this one. L C K P to the power K 1 minus P to the power L minus K. That was the case. Now out of L minus 1, K minus 1 reject. So K minus 1 times P. So P to the power K minus 1. And the remaining means what? L minus 1 minus K minus 1. There are the remaining part where we are getting 1 minus P. So definitely 1 minus P to the power L minus 1 minus K minus 1. Can you understand this one? I need the feedback.
Can you repeat again, sir?
Okay. Let's go back. Let's go back. Five. So I will say R, and how many is the N? N equal to 1, 2, 3, 4, 5, 6, 7, 8. N equal to 8. So out of 8, there are 5 reject. So what is the binomial theorem? 8 C5 and then 5P. So P to the power 5 and then 3 1 minus P. So 1 minus P to the power 3. That was the binomial theorem. Can you remember?
Yes, sir.
In the last class, we talked about this one. This 3 came from where? This is coming from 8 minus 5. So if I write general equation, it will be N C X P to the power X 1 minus P to the power N minus X. N is what? Total number of tests. What is X? Number of reject. Can you remember the binomial theorem?
Yes, sir.
Okay. If you know the binomial theorem, then The same thing is true. Now, look at this. This is the same thing. What I'm telling, you test circuits until you find K rejects. This is the same thing as we have seen in the binomial case, because this one is what? This one is something like the same thing. If I just break it in two parts, the last part is always a reject. If I say, because out of L, K reject. So if the last one is a fixed reject, actually if I ignore that, then this part, can you listen to me? Can you listen to me?
Yes, sir.
Okay. So this part is what? L minus 1. The whole part is L. This one less means L minus 1, isn't it? And if I take L minus 1 tests are done, and then P, 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 P. Say 5 P's are there. So this P, and of course the last one is a P. So 6 P are there, isn't it? So if the 6 is the K, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So L equal to 13 and K equal to what? What is K? Tell me what is K? K equal to 6.
Minus 1. Oh, wait.
How many P's are there? 1,
5.
2, 3, 4, 5. And the last one is a P. So 6 P. 5, last one is a reject. So how many total reject?
6
Rejects, isn't it? So K reject, yes. Any question? You can ask.
Sir.
Yes.
So are we not considering up to L minus 1?
We will consider L minus 1. We are coming.
Sir,
We
I'm
are
saying,
coming,
are we
but
not
L,
considering up to L minus 1? So should K not be 5?
yes, we will. No. K is what? K is the total number of reject.
Okay.
Suppose you test circuits until you find K rejects. Until you find K rejects mean what? The last one is a reject also. So K is the including the last one. So if I want to take up to L minus 1, then how many rejects? K minus 1 reject. Isn't it?
Okay. Yes, sir.